So this is going to be a video about basic algebra. We're going to just discuss today problems that look like this. So we had 4 plus x equals 6. Alright, so we can take a problem like this, and it's important to remember a couple things. First, remember that x is a variable. Now a variable can change. It can be any number. It stands in for anything. It can be any letter as well. So even though we use X here, we could use Z, Y, W, M, P, Q, any letter to stand in for any number. It just means that this is an unknown in the which we're going to solve. Now, there's some basic algebraic operations that we can use to solve. We can subtract, multiply, so we can subtract, we can multiply, and then we can divide. And we can also add. So just remember these 4 basic operations for now. They'll add more later, but now these operations are enough. If we have something that looks like this, the object is to get x by itself on one side of the equal sign. So something we can do is we can draw a line down from this equal sign saying that whatever happens on one side is one side and whatever happens on one side is the other. But an important rule in algebra is that whatever you do to one side, you have to do to the other side. So if I wanted to add a 3 to this side, I would have to add a 3 to this other side because they have to be equal. So no matter what I do, both sides must equal what they originally equaled. That way it keeps the equation stable. So in order to keep in that spirit of keeping both sides, we can add or subtract. Now we have a plus 4 here, plus x minus or equals 6. Now x doesn't have a number in front of it. That's nice. We can imagine a little 1 here, but it's not necessary. So we don't need to worry about the x. Now this 4, we have an add 4, so we need to do the opposite operation and minus 4. Giving us x. Oops. After we do that, these cross out, equals 2. So if you see, we did this to make sure those disappeared. Then we did this because we had whatever we do to one side, we have to do to the other. Now let's view another problem that's similar. Let's take one from the textbook. All right, so we're going to take problem from 3-point A. Most of these are simplification. Oh, there we go. Here's ones that are solved. So we're going to take problem 17 from 3.1A. So all right, so we're taking problem 17. That's what it looks like. So we need to write the problem in terms of x equals. So in the end, we're going to have x equals something, right? So just for the sake of easiness, I'm going to write it like we did this way. This is the same as this. Whatever's on one side of the equal sign, you can interchange it with the other side. It means the same thing. You can do that anytime. If it's easier to see it one way, you can rearrange it and it looks that way now. So now we have this. We have a plus 5x plus 7 minus 13. This problem is interesting because we have a number here. So now we have to do something with that, but we can't until we remove this 7. This 7, when it's addition or subtraction, a number next to the x is multiplication. And so since it's multiplication, we can't divide until we remove this 7, or we have to divide the 7 by 5. Let me show you what I mean. If we wanted to divide everything by 5 right now, we'd do this. We'd say we want to divide by 5, but that 7 is still there and it didn't get divided, so we have to divide that, and then we would divide by this. And we get a bunch of fractions, but we don't want that. We don't want a bunch of fractions. Fractions are hard to deal with. If we can avoid it, we don't want them. So the better thing to do is to get the thing with x, the number with x, get that alone on one side before we do any division or anything. It'll make our jobs a lot easier. So if we say that we have 7 minus 7, we're going to minus 7 because we have plus 7. So in order to make that cancel out, we have to minus 7. We're minusing 7 from each side. Now, the reason that minusing doesn't work the same as division is because multiplication and division affect the whole side. When subtracting and adding will affect the side, but they'll only cancel out with the number that they match. When multiplication and division do something different, and we'll explain that when we talk about the video of simplification. And so there's this video, which is on basic algebra, and then there's a video for simplification. Now those cancel out, and we're left with 5x equals negative 20. So remember again, this is a positive 5. So what we're going to do now is, since this is multiplication, there's a multiplication symbol right there. Between those two, we'll divide, because we don't want the 5 on that x. That just makes the problem difficult. Divide by 5, and then x equals negative 4. All right, so let's run through those steps real quick. We first get the number and x alone. We get this guy to be alone. We want him to be just on one side. So we say, okay, now we've got 5x, we've minused our 7 over. 13 minus 7 is negative 20. Now we divide, because this is a multiplication problem. Now if we had a problem like this, let's remove this. All right, move that. If we had a problem like this, or it can also look like this. We need to get a number that will remove this 5. These are the same problem. They equal the same thing. They all equal 3. But now we need to solve for this variable, this x. In this one, it's easy to see. If we have a division problem, we multiply by 5. Those cancel out. But whatever we do to one side, we have to do to the other side. So we're going to multiply that side by 5. That gives us x equals 15. In this one over here, it's not as apparent. When we multiply a fraction, we multiply straight across, right? So this is technically x over 5. But we can also say, if we were to wanted to remove this 5, we just multiply both sides by 5. So if we multiply both sides by 5, well, that x is in there too. Then we get this. The 5 and the 5 cancel out, because this becomes 5 over 5 times x equals 3 times 5, 15. And 5 over 5, this is just 1. So now x equals 15. So when you're solving for algebra, remember your order of operations. Remember the common mistakes that you can make. Always, before you multiply or divide one side of an equation, make sure your x is by itself with a number. You can't have any plus 7s, minus 7s. You can't have anything that's going to cause your division to go haywire. Let's do one more, because I think we have the time in this video left. Let's do number 13. So if we do number 13, let's see if I can get this copied correctly. Oh, nope, it did not. All right, that's fine. I'll write it down. So it's 5 times 3x minus 1 over 7 plus 2. So 3x minus 1 over 7 plus 2 equals 35. So it's tempting for us to just minus the 2 over, but we can't because it's inside the parenthesis. So the first thing we have to do is divide by 5. That'll cross that out. If we divide that by 5, we get, so we're doing our line down the side here, 7 on this side, and 3x minus 1 over 7 plus 2. Now we can't say that we can't just multiply by 7. It doesn't work. We'd have to multiply the 2 by 7 if we did that. So now we're at the point where we have to subtract the 2. So we can get the term with x all alone right here. So the term right here with x, we have to do that and get that all alone. So we're going to minus the 2. 3x minus 1 over 7. And that equals 5. We're going to multiply by 7. Multiply by 7 because we have a 7 on the bottom. Now we're going to say, well, that's 35 on this side. And 3x minus 1. And then we add 1. So now we're left with 3x equals 36. And then divide by 3. And that will give you your answer. And so the object of this is to produce x alone, but we have to go through various steps to do so. If we don't follow the steps correctly, we won't get what x equals. It's just not going to happen. And it takes a lot of practice to get these steps to where you can memorize them. And so I would watch this video a couple times till you understand the subject. Email me if you have any questions on it. I'll see what I can do to help out. But just work on your basic algebra, try to remember what the rules are, and that will help you immensely when you go to do the math. But yeah, that's how you do basic algebra.